With our drawing in hand, we now need to find the relations between the variables in our problem. So here's m and f, and so it's a force problem. We know we're going to use Newton's laws, so we're going to go ahead and write F is equal to ma. This is how the force and the acceleration of the rocket are related to each other. And so the only unknown here is a. So I'm just going to go ahead and solve for a. So the acceleration of the rocket is F divided by m. So we are told F, we are told m, so now we know the acceleration of the rocket. And so since the rocket has a constant acceleration, we know that its motion is going to be described by the kinematic equations. So I'm just going to go ahead and write down the kinematic equations. This is me writing the kinematic equations from memory. And same thing for the velocity. And so now what we can do is we can go ahead and use our picture to replace the various things that we know in this equation. So we are interested in a final time t, just some arbitrary time t. So x of t, that's the thing that's the final position, is going to be equal to the initial position, which is 0, right? So that's 0. The initial velocity, that's 0. So this, it's going to be 0 as well. And so we are left with 1/2 a t squared. And notice, we know what a is. We were told f in the problem, and we were told m in the problem. So we know what this thing is. This is a complete solution. This is the position of the rocket as a function of time. And if we wanted the velocity at time t, that final velocity, is just going to be a times t. And so this is our final solution.